As I said before, for these volumes, you often have a choice between your disk washer and your shell method. Sometimes you don't. Sometimes it's really difficult to solve for the other variable. Sometimes it's impossible. So it might make the shell method a necessary method. And that's what we're going to see here in number 5, that we actually can't do it with disk and washer. So we're going to find the volume of the solid found by revolving the region bounded by these graphs about the line x equals 2. So to graph this first, let's see. First I'm going to graph this y equals x cubed plus x plus 1. If I plug in 0, I get 1. It's obviously some sort of cubic thing. So 0, 1. If I plug in 1, I get 1, 2, 3. Okay, so it's coming up kind of like this, just a little piece of it. We have the graph y equals 1, which is right here, x equals 1, which is right here, and we are revolving this about the line x equals 2. So here is our axis of revolution. So the rest of this is going to look like it's coming over here and down. Hopefully that looks okay. It's a circular thing. Okay. There. That's what that looks like, all revolved. So let's see. If you wanted to slice this, you would have to slice perpendicular to the axis of rotation. So if you wanted to slice this into disks and washers, this is what they would look like. And notice that would be in the dy direction. So that means you would have to solve this thing for x. We can't do that. Okay, so disk method, washer method, it is not going to work on this one. So we have to use the shell method. So let's get rid of those. We're going to take a look at our shells. Okay, I'm just going to draw one of them in here. Here it is. Okay, this particular shell. And so notice those shells are going to be in the dx direction. And so we're already set up for that. So our shell method is going to be, remember, it's 2 pi, and we have the radius times the height, the function of the radius, the function of the height. We already said it was dx's. So we'll start plugging in what we need here. So 2 pi, in the x direction, we are going from 0 to 1. And we need to think about the radius of this thing. The radius of that. Okay. So this portion of it over here, let me get a different color. This portion of it, that's just our x value, maybe it's 1/2 or something. We need this radius. That radius is going to be 2 minus x. Okay. Remember from last week when we revolve around something that's not the axis, we often have to do the subtract from our axis of revolution, and that's absolutely happening here. Then our height function, the height of this, is going to be determined by our function, which is going to be x cubed plus x plus 1. But notice we don't get all the way down. Remember, this doesn't go all the way down. We stop here at y equals 1, so we have to subtract 1. And that's happening because this region that we're dealing with, we have basically top curve minus bottom curve here, so it cuts off. So dx. Okay. So now we are set up for shell method. So we have 2 pi, 0, 1. These obviously cancel. So this thing here in purple, I'm going to FOIL that out. So when I FOIL it out, I get negative x to the 4th. I'm kind of skipping a step here just for time's sake. 2x cubed minus x squared plus 2x. So that's all FOILed out. We're going to take the antiderivative of that. So we get negative 1/5 x to the 5th plus 2/3 Nope, that's wrong. Got a little ahead of myself. That's going to be 2/4. So 1/2 x to the 4th minus 1/3 x cubed plus x squared. We're going to evaluate that from 1 to 0. Hopefully that's all okay. I think we're good. Okay, we're going to plug in 1, and then we're going to plug in 0. When we plug in 0, it's just going to be 0. So we really only have to worry about plugging in 1. So we get negative 1/5 plus 1/2 minus 1/3 plus 1. And you can get common denominators. That's just basic math. When you do all of that, you end up with 29/30. So final answer will be 29 pi over 15. Okay, so like I said, make sure you're drawing the picture well so you can decide whether the disc or the shell method is going to be best. A lot of times you really do have a choice, but other times you don't. The one method might just get too complicated or actually impossible for us to solve and integrate. So make sure you're drawing good pictures so you can make good decisions about which method you're going to use.